Welcome to this presentation. In this training video, we will show you the different non-helical pile types that you can design with our DeepFND Deep Foundation design software, how you can define different non-helical pile sections, and how you can review the results, interpret them, and optimize your pile. On the model area of DeepFND, we can double-click on the pile, and in the dialog that appears, we can define the pile type from up here. So in DeepFND there are two options. The pile can be non-helical or helical. In this example we are gonna present the non-helical piles. So if we leave the non-helical pile selected, we can see the different installation methods and we can choose from here. So a pile can be drilled, driven, a caisson, a micropile, a CFA pile, and a drilled-in-displacement pile. These options are available. So if I select one of these options, let's say driven piles, and press OK, then the software will ask me if we wish to change the recommended FHWA or ASTO settings for the driven piles, because I changed the pile installation method. If I press yes, and if we go to the analysis tab, we can see now that the different methods are selected for driven piles. If I go back to the pile and change to drilled and press OK, once again I will be asked if I wish to change the settings. I press yes, and now all the settings are selected for drilled piles. So all these options are selected automatically based on the pile installation method from here. Down here we can choose to define the coordinates of the pile head. The X coordinate along my screen, we should leave this 0, and with this we'll place the pile on the center of the screen here. The Z is the pile head elevation. So now it follows the ground elevation, but if I change to something else, let's say 6 feet, and if I press OK, we will see that the pile moves above the ground or below the ground surface. We can set this from here. This is a vertical pile, so the installation angle is 90 degrees. This is the angle from the horizontal. So if we need to have a battered pile, we just need to change this installation angle. This free length, usually this is 5 feet or 1.5 meters. This is the top of the pile, and it will be not taken into consideration in the shaft resistances. Typically we will leave this at 5 feet. Here we can define the pile section. So in DeepFND you can have a composite pile section, you can have a pile section that changes along the pile depth. So here you just need to define a length. If we say 30 feet, so this changes this part of the pile length, and here we can select the structural section for this part of the pile. There is a default option, this 5-foot pile, which we can press this button in order to edit. So now here we can edit the 5-foot pile, and we can also add as many sections as we wish. This will populate this drop down, allowing us to assign different pile sections along the pile. If we define a different length, and we can select a different section from this drop down, which will be now populated with these new sections that I just added. Each of these sections can be a circular, a rectangular, circular hollow, an octagon, a steel pile, or a timber pile. So these are the available pile types here. We can select any of these. Let's say a steel for this one, new section 1. We can edit, of course, the name. We can define the concrete and rebar steel materials from here. And here we can press this button in order to edit the steel section. Here we can select to use an H-beam, choosing an H-beam section from the extensive database within the software program. We can choose a pipe section, choosing a pipe from our database. or even a hollow section, a square hollow section, choosing something from the list. We'll go here and I will select a W21 for this one. Let's say a W21 101. Here we have to select an FY for our steel material. So there is a database that we can choose from, or we can manually go here and we can type our steel material property. All the properties here are automatically defined and are included in the software database. So if I press OK, now this steel section will be added to the model, to new section 1. If I go to new section 2, and let's leave it circular, we can choose here, if it's reinforced concrete, the size of the rebbers and how many rebbers this section will have. Let's say 20. And also we can define the shear reinforcement. If we wish, we can also create a composite section. We can define less rebbers perhaps, and we can go to the steel sections and we can choose to add a steel section. And if I press edit here, I will choose the same steel section W21 101. From here, let's say the same material as before, and if I press OK, it will put the steel section right inside the pile. And if I press OK, now I will see here I will define a new section 2, so the pile for 30 feet will be like this with the steel beam inside, and let's say for the next 20 feet I wish to use new section 1, which is the pile, steel pile only. And if I navigate along the pile from here, I can see the section changing in depth. This way you can put as many parts along the pile as you wish, and you can define the same or different pile sections from here. I will press OK and I will see the pile changed on my model area. In DeepFND there are two options here. We can have in the general tab this option selected, and here we can define a maximum depth where we wish our pile to go to and a step. So the software will start from this L3, which is typically 5 feet, and it will start going down in depth, calculating with this step the bearing capacity and the shaft capacity. It will compare it with the applied loads, so it will calculate the compressional capacity and the tensional capacity of the pile. It will divide it with the safety factor that we have defined in the design tab. In this case it is 2. And it will compare this result with the applied loads. When it finds this spot where both the compressional capacity and the tensional capacity divided by the safety factor are more than enough to cover both the compression and the tension load that we applied, it will stop the analysis and it will return this as a result, this depth, along with the calculated capacities. If it goes down to this 45 feet and it does not find a suitable depth, it will stop the analysis and it will return us as a result that it couldn't find a suitable solution, and it will report the calculated capacities for this depth, 45 feet, that I have here selected now. If we unselect this option, then the software will keep the specific depth and the sections as I have defined them. It will calculate the bearing capacities, and it will give me as a result the bearing capacities and a ratio, the bearing capacities divided by the applied loads. Let's see this option first. So I leave it like this and I press this button in order to calculate the selected design section. The analysis will do some seconds. So now the analysis finished. As soon as the analysis finishes, this analysis and checking summary table appears. And here we can review the different properties for all these items for the different design sections. We are now currently interested in the base model, which is the one that I modified and analyzed. So here we can see the maximum compression load and the compression capacity of this specific pile, the maximum tension load and the tensional capacity, which leads us to this maximum stress check, which is above 1. This means that they fail, and it's normal. The compressional capacity 84 is not enough to cover this applied 200 load. The same with the tensional capacity here. For the lateral design, we see that this 10 kips lateral load produces a 0.04 inches lateral displacement and the moment. And if I exit, I can also see the results on the screen. The calculated ultimate tensional capacity is 138 and the tensional capacity is 69. It's this divided by the safety factor. The same with the compressional capacities. So this pile fails in tension and compression. We need to do something to increase the pile. So I'm going to apply here the 5-foot pile with the reinforcement. I will assign it everywhere. We will run the analysis once more. So now we see in this case with the reinforced concrete section the calculated compression and tensional capacities are more than enough to cover the maximum compression and tension load. And we can see also that there is a lot of space for us to use a shorter pile. So in this case I will exit and I will go to the General tab where I will choose to optimize the pile length. I run the analysis once more. Now the software will do some seconds more because it calculates the bearing capacities in different depths, and it will report us this depth where both the tensional and the compressional capacity were more than enough to cover the maximum compression and tension load. In this case we can see that the governing is the tension load. We have a lot of space for the compression, but this section in this specific depth, which we can see here, 31 feet pile depth, produced enough tensional capacity to cover our applied tensional load. And if I go to the right, I can also see the lateral load and the lateral displacement that this load produced. If I exit now once again, we can review the capacities, we can review in every stage. And here in the results tab on the right I can see also the wall moment with the moment capacity as it is calculated for every stage that I have a load. We can see the piles here and we can see the pile head displacement diagram. So we can see the pile displacements along depth for different stages. Now, if we do a settlement analysis, if I go to the settlement tab, I choose to perform a settlement analysis. Here we have different pile acceptance criteria that we can choose from. We have Elastic, ICC, Davison's, New York City, etc. So we can put any of these criteria, let's say Davison's, I press OK. And if I run one more time the analysis, the software will also report us the pile settlement along with the acceptance criteria. So if I exit, we can go here and we can review the pile head settlement diagram. Visit our websites in order to review additional information on our software programs, useful theory, documents, examples and training videos. If you wish to receive our pricing, special offers, or if you wish to arrange a free online presentation, feel free to contact us. Thank you for watching this video.